Here is Usama Shahab, your chemistry teacher. Hope you all are safe, fine and healthy. Today we are moving towards the most important topic of grade 11, which is moles. Moles and stoichiometry. So initially we have to discuss about moles first. Then we will move towards stoichiometry. So what is moles actually? Definitely you all know about atomic number and atomic masses. What is atomic number? It is actually the proton present in the nucleus of an atom. And what is this? It is the sum of protons and neutrons present in the nucleus. So we talk about this one. What is this? It is mass of atom, which is atomic mass, and it is actually the sum of protons and neutrons in the nucleus. And for example, if we talk about molecule, so the sum of all atoms present in a single molecule and the sum of all the masses of atoms present in the molecule is actually molecular mass. And if we talk about compound, so the mass of all atoms present in a compound is known as formula mass. So we have different masses, and if we consider all of them in gram, so they become the 1 mole is equals to 1 mole and it's equals to 1 mole. So that means the atomic mass of an atom is considerable as 1 mole of that atom, and then 1 mole can consider as a molecular mass of a specific molecule. Then 1 mole is actually the formula mass of a specific compound. Let's have an example. Yes, so going towards example, so for example, if you talk about an atom, so example for atom, let's suppose we are talking about chlorine atom. Okay, so the atomic mass of chlorine atom is 35.5 gram. Okay, and for example, if we are talking about molecule, so it is molecule of chlorine gas, and what is the molecular mass of chlorine gas? It will be 35.5 into 2, it will give you 71 grams of chlorine gas. Then for example, if we talk about compound, so let's have an example of NaCl, which is a compound, and 23 for Na, 35.5 for chlorine, it will give us 58.5 gram of NaCl. Okay, so it is actually 1 mole. It is actually 1 mole, and it is actually 1 mole. Okay, so this is 1 mole of chlorine atom, this is 1 mole for chlorine gas, and this is 1 mole for NaCl. So you can see over here that we have different masses in 1 mole. It all depends on the atom, the molecule, and a compound. That the mole contain that atomic mass of any atom. For example, if you are taking sodium, so it is 23 gram. So that means it is a 1 mole of sodium atom. If you are taking iron, so it is 56 gram. It is 1 mole of iron. So actually, when we talk about atom, so the atomic mass is actually 1 mole of that atom. Okay, atomic mass is actually 1 mole of that atom. But if you talk about molecules like chlorine gas, oxygen gas, like nitrogen gas, so they all have different masses, like 71 gram, like 32 gram, like 28 gram. So these are 1 mole of these molecules. So each and every mole has its own mass. For example, it is 1 mole of chlorine gas, it is 1 mole of oxygen gas, and it is a 1 mole of nitrogen gas, depend on their molecular masses. For example, if you talk about compounds, so it is calcium carbonate. Calcium is 40, carbon is 12, oxygen is 16 into 3, so it will be 100. So 1 mole of calcium carbonate contain 100 gram, depend on its molecular mass. Sorry, it is a formula mass because it's compound. Okay, so if we talk about moles, so I just tell you what is mole. Mole is actually atomic mass, molecular mass, and formula mass. Okay, so it is for atoms, and it is for molecules, and it's for compounds. Just remember this. Okay, for example, I just have 142 gram of chlorine gas. So how many moles we have? Definitely we know that 71 gram of chlorine is equals to 1 mole. So if we have double mass of it, so definitely it is of 2 moles. For example, it will be 35.5. So what happened with chlorine? So it will be 0.5 mole of chlorine gas. Okay, that is just, you can say that we are taking unitary method for this, but how long we do this? It's impossible for us now. For example, if we have 200 gram of chlorine, so how can we estimate that it is 0.1 or it is 1 or it is something else? So for this we have a specific formula to find out moles from masses. Okay, and the formula is moles is equals to mass over molar mass. What is molar mass? We are taking all of these as a molar mass. Okay, so we can use all of them once in the formula. What is molar mass? It is actually mass of 1 mole. So we know that the atomic mass of atoms is 1 mole, the molecular mass of molecules is 1 mole, and the formula mass of compound is 1 mole. So we are taking all of them as molar masses, means masses of 1 mole. Okay, either it is atom, it is molecule, and it's compound, doesn't matter. We are taking all of them as a molar mass. Okay, so right now we are going to find out mole for 200 gram of chlorine. So it has given to us that we have 200 gram mass, so we can write 200 over here, and we know that chlorine gas means Cl2, and the molecular mass and the mass of 1 mole of chlorine is 71, so we can write 71 over here. So if we divide 200 by 71, so we'll get 2.816 moles of chlorine gas. So this is how you can calculate moles when you have masses. Okay, let's have some more examples. For example, we are moving towards calculate the number of moles in we have a question of calculate the number of moles in 275 gram of calcium carbonate. Okay, so now what we have to do over here, that we know that simply we have a formula that mole is equals to mass over molar mass, right? Molar mass means mass of 1 mole. Okay, so we are talking about the mass of 1 mole of calcium carbonate. So it is calcium, which is 40, it is carbon, which is 12, and it is oxygen, which is 16. So it is 40 plus 12 into 3, it is 48, so it will give us 100. Okay, so the 1 mole mass of calcium carbonate is 100, and given mass in the question is 275, so we can divide it by 100, we will get what? 2.75 moles of calcium carbonate. Okay, that is how we can calculate the number of moles. Okay, you can calculate even any number of moles. For example, let's have an example that we have 200 gram hydrogen gas. Okay, calculate the number of moles. That is not a big deal. We can calculate even the number of moles for this. How can we calculate? We know that moles is equals to mass over molar mass. We have 200 gram hydrogen, and right now 1 mole mass for hydrogen is 2, so it will give us 100 moles. Okay, so students, this is how we can calculate moles. Okay, and one more method that how we can calculate moles if we have number of particles. So for this you have to know about Avogadro number. Okay, and what is Avogadro number? You have to know it, that it is a value. Okay, Avogadro number is 6.023 times to the power 23. It is a value which tell us the number of particles. Okay, which type of number of particles we are talking about? Number of particles means it may be number of atoms. If we talk about atoms, so if you find moles in atoms, so definitely Avogadro number tell about the number of atoms. Okay, it can even tell about number of molecules if you are talking about molecule. Okay, and then if you're talking about molecules, so it can even tell about the number of atoms as well. For example, if you are talking about chlorine, so we can take out the number of moles of chlorine, and if we multiply it with the Avogadro number, so it will tell us the number of molecules present in that mole. Okay, but we know that this molecule of chlorine contains 2 atoms as well, so we can even calculate the number of atoms by this, by multiplying it by 2. Okay, so if we are talking about formula that compounds, so it contains positive and negative charges as well, so it can tell us even number of ions. Okay, it can tell us even number of bonds. So we can calculate all of these things by Avogadro number. So actually, what is Avogadro number? You have to know about it. Okay, so we remember this point: 1 mole always contains 6.023 10 raised to the power 23 number of particles. Okay, number of particles mean it includes all of these things. Okay, we remember this. You can take out number of particles by moles, and even you can take out moles as well by Avogadro number. Okay, so let's have an example for this as well. So if we are moving towards like this, calculate the number of atoms. Okay, calculate the number of atoms from like 100 gram oxygen gas. We are going to find out the number of atoms in a molecule. Okay, first of all, what we have to do, we have to calculate mole. Okay, and we know that we have 100 gram, that is mass. Okay, and we can even divide it by molar mass of oxygen, which is 32. Definitely 16 into 2 will give you 1 mole mass of oxygen is 32. So you can divide it by 32 and you will get the answer. If you divide 100 by 32, you will get 3.125. These are moles of oxygen in 100. And we know that according to Avogadro number, we know that 1 mole is equals to 6.023 10 raised to the power 23 number of particles. Okay, so this time what is particle? This time we are talking about molecule. We are talking about molecules. So 1 mole contain number of molecules right now. So it is for 1 mole. Right now we are going to find out number of molecules in 3.125 moles. So what we have to do, that's quite simple. We just have to multiply mole with Avogadro number. Right now we have 3.125 moles, and what we have to do, we just have to multiply it by 6.023 times the raised to power 23. Okay, so if you multiply 3.125 into 6.023, you will get what? You will get 18.82 into 10 to the power 23 number of molecules. It is number of molecules. Okay, but what we have to find? We have to find out number of atoms. So what we have to do? We know that 1 molecule of oxygen contains 2 atoms of oxygen. So we can multiply it by 2 to get the number of atoms of oxygen in this. So it will be like this. Okay, so we can even calculate number of atoms by Avogadro number. Okay, let's have one more example. Okay, for this, for example, I'm just going to erase all of these things, and I'm talking about calculate the number of bonds in methane. Okay, and how much methane we have? For example, we have like 50 gram methane. Okay, so first of all, what you have to do, you have to find out mole, and it is mass over molar mass. And what is the molar mass of methane? It is actually CH4, so it will be 12 plus 4, it will give you 16. So it is like 50 gram divided by 16, so it will give you what? It will give you 3 point something, definitely. So 50 divided by 16, so it will give you again 3.125. Wow, that's good. Okay, then we are moving towards number of particles first. Okay, so right now what we have to do, we just have to multiply it by number of particles. Right? It is molecule, it is a gaseous atom, and it contains covalent bonds, so it is molecule. So let's find number of molecules. And what we have to do to find out number of molecules is quite simple. Just multiply mole with Avogadro number, and it will be like 3.125 into 6.23 raised to the power 23, and we will do the again same answer which was previous, 3.125 into 6.023. It will give you 18.82 raised to the power 23 molecules. Okay, it is a number of molecules. It is not a number of bonds. We have to find out number of bonds as well. So let's have a diagram for methane. It is like CH4. So how many bonds we have right now in a single molecule of methane? 1, 2, 3, 4. So to find out the number of bonds, what we have to do, we just have to multiply the answer with 4. And this way we are able to find out number of moles. Sorry, that is not a number of moles. These are the number of bonds. Okay, so these are the number of bonds that are present in 15 grams of methane molecule. Okay. Okay, so that is about Avogadro number as well. So you just have to make connections to do work more easy like this. For example, if you talk about moles, so you have a formula, it is mass over molar mass, and we know that molar mass is constant. We can find it out by periodic table as well. So we are not talking about molar mass, we can find out mass as well if the moles are given. Okay, so what we have to do, if the moles are given, we just have to multiply molar mass with the number of moles, so you will get mass as well. Okay, these are the two different things that you can find out by this formula. Okay, and same for this, we can find out number of particles if the number of moles given. So you can do like this, right? For example, if the mass is given, so you can find like this number of particles, but you have to find out moles. And for the finding of moles, what we have to do, we just have to divide mass over molar mass, and then it should be multiplied with Avogadro number. And if the number of particles are given, so you can find it out by dividing it with different Avogadro number. Like I'm just showing you the formula. For example, you have to find out moles. So what you have to do, if the number of particles are given, you just have to divide it by Avogadro number, right? So you will be able to find out number of moles. And once you get the number of moles, you can find it out this formula to find out the mass. Okay, so for example, I just write over here, you can find it out. It is 1, 2, and 3. So total we have 5 formulae, and that we can use all of these different formulae to find out different things, but they are ultimately just 2 formulae, 1 and that is 2. Okay, one more formula for moles is equals to, you have to remember this, it is specifically for gases only. Just remember this. The note for this, you have to remember this: 1 mole of any gas always contain 24 decimeter cube of volume. Okay, 24 decimeter cube of volume. It is just journal. 24 decimeter cube is journal. You can write it as 22.4 decimeter cube. You will find somewhere like this. So if in your exams it will be 22.4, that is accurate. Okay, and it is journal, just remember. So you can use this one and this one as well. that is not a big deal. Okay, but I prefer you to use this one because this is accurate one. Okay, so for example, if you want to find out the moles for gases, it is only for gases. So we remember this, it is like the volume which is given to you and divided by 24 decimeter cube, so it will give you the moles of that gas. Okay, that is all about moles. And now we are moving towards stoichiometry. Okay, and stoichiometry is just about the relation. It is about its relations, right? Okay, and we are moving towards relation now. Okay, so if you talk about stoichiometry, we have different ratios between two different things. Like we can even use the mass relation. Okay, what is mass relation? It is like a mass of reactant is given and you have to find out the mass of product by the use of equation. And you can use it is mass relation, it is mass volume relation. For example, mass is given and you have to find out volume, and then volume relation, volume is given and you have to find out volume as well. So this is all about stoichiometry, that we have to use equation for this and we have to find out the masses, volumes, and you can find as well number of moles, you can find number of particles, number of atoms, number of each and everything by the use of stoichiometry. Let's have an example what I'm talking about. For example, an equation is given to you like this, 2KOH, okay, and it is reacting with sulfuric acid, and what's happening in the product, potassium sulfate is formed with 2 moles of water. Okay, it is a balanced equation. For the stoichiometry, you have to need balanced equation. You have to use balanced equation. Without a balanced equation, you are not able to do like relations. Okay, so 14 gram, for example, 14 gram KOH is given, and the question is you have to find out the mass of potassium sulfate that is formed by 14 gram. Okay, so what we have to do, first of all, we have to find out the moles for KOH. Okay, moles for KOH, and we know that the formula is mass over molar mass, and we have 14 gram mass. And what is molar mass? We have K is 39, oxygen is 16, and hydrogen is 1. Okay, so it is like 58 almost, and when we divide 14 by 56, it will be 56, sorry, it will be 56. So when we divide 14 by 56, it will give us almost let me calculate, it will give you 0.25. okay, these are the number of moles of KOH, and what we have to find out, we have to find out the mass of potassium sulfate. So let's see, according to the equation, we have to use equation. According to the equation, what is given to us? It is potassium hydroxide, and what we have to find out? We have to find out potassium sulfate. Okay, so we just use these two, and the rest two will be left. Okay, we are not going to use these two. We just have to find out potassium sulfate and through potassium hydroxide. So we use just these two. So what is the relation according to equation? It is 2 and there is nothing, that means 1. The relation is 2 and 1. Okay, that means if we have 2 potassium hydroxides, so the potassium sulfate will be half of it. Okay, so if we have 0.25 moles of potassium hydroxide, so it will be, if it half this, so it will be like 0.125, right? According to equation, it is given that 1 mole of potassium sulfate requires twice of it, right? Potassium hydroxide. It is given in the equation, you can see over there, right? And then if we have 0.25 potassium hydroxide, that means if we half it, it will give us the number of moles of potassium sulfate, and that is the number of potassium sulfate. We got it. Okay, and we know that. How can we find out the mass? It has like moles into molar mass. Okay, MR. So first of all, we have to find out the MR of potassium sulfate. It is like potassium is 39 into 2, sulfur is 32, oxygen is 16 into 4. So it will give you 174, right? So mass we can find out, moles 0.125, molar mass 174, right? So how much mass we will get? 21.75 gram mass for potassium sulfate. So if we have 14 gram KOH, so it can produce 21.75 gram of potassium sulfate. Got it? Okay, moving towards another example. Let's clear of all these things, and we have an example like magnesium reacting with hydrochloric acid and forming magnesium chloride with hydrogen gas. Okay, it is gas. I mean that is soluble salt, so it is aqueous, yes, acid, aqueous, and it is solid. Okay, so for example, it is given to you that you have, for example, you have 50 gram magnesium. Okay, and you have to find out the salt which is formed and the volume of hydrogen gas. Okay, you have to find out mass and volume for this. That is not a big deal. You have to find out number of moles for this, and we can use the formula. We know that. What is the formula? We can use mass over molar mass. So we know that what is the molar mass for magnesium? It is 24, so it will give you 2.083, okay, moles of magnesium. Now we can use this for relation. So I'm just taking two parts for this. One for, definitely we are just using magnesium and find out this and this as well. So we just take relation with magnesium and magnesium chloride, and then magnesium with hydrogen as well. So both has one relation, so it is like 1 1, and over here it is also 1 1. So it is 2.023, 2.083. That means the moles for magnesium is also 2.083, and same for this as well. So it is quite easy for us to find out the number of moles in this equation. So we can easily find out the mass as well. We have to find mass, so we know that the formula for mass is moles into molar mass, and here we have 2.083 moles. And what is the molar mass for magnesium chloride? It is 24 plus 35.5 into 2. So it is like 35 into 2, it will be 71, and then 71 plus 24 will give you 95, and you multiply it by 2.083, and it will give us 197.885 gram mass. Okay, it is simple, and we know that for gases you have to find out volume. It is quite simple. We know that 1 mole of any gas at standard temperature and pressure will give you 22.4 volume. So if you want to find out volume, we have moles, we just have to multiply it by 22.4. We can multiply 2.083 by 22.4, so we'll get the volume of hydrogen gas as well. So it will be 46.6592 decimeter cube. Okay, let's have some change over here. Like if you want to find out the number of atoms in this one first part, so what I have to do, just I need to do something like this till moles it is same, and then I can do like it is a compound, so I can do like this. We know that these are moles, and for the number of particles, what we have to do, we just have to multiply it by Avogadro number, moles into Avogadro number. So we have 2.083 and then 6.3, right? You can multiply it like this, and what will be the answer? We will multiply it by 3 because we have 3 atoms in single formula of magnesium chloride. So it is 2.083 into 6.023 10 to the raised power 23, and it will be like 12.5459, and then we multiply it by 3. Okay, when we multiply it by 3, so it will be 37.637 10 to the raised power 23 number of atoms. So we can even find like this. They can relate anything with this stoichiometry, so you have to remember all of these things. Okay, thank you so much for your time and attention. Take care. Allah.